Getting the most out of your workflows can be really important, especially if you run them regularly and they use an event-driven architecture. I was interested to discover how can I test the performance of my workflows to help me understand if changes I'm making are actually making them faster on average. Now, some changes you might make, maybe a quick setting here or there, you can maybe see big performance improvements. But what I want to look at is changes that may take multiple executions to see that improvement. So let's have a look at a workflow I created to help me track performance of other workflows. Now, I decided to make a workflow here that could, when specified with the flow ID and namespace, as well as how many times you want to run it, you can then have it use a subflow to run that workflow multiple times and collect the duration it took for that workflow to get an average, because some tasks may take way longer than expected in one run because of latency from another system. So it's best to run these things over a larger number of executions to avoid any anomalies. So to do that, as you can see here, I've got my subflow here that is going to run inside of a for each block. And what this means is I can then specify run it 10 times, and then it will run it 10 times, calling that subflow each time. But once the subflow has finished, it will then use the Kestra API to get the execution data, such as the duration. And then here you can see I'm using a GraalVM Python task because it allows me to get that duration out when using the expressions here along with a little bit of Python just to get the answer I'm after. After that is all run and we're outside of our for loop, then we'll get to the calculate Python task. Again, using the GraalVM here for convenience, because here I want to get the total average, how long it took across all my runs to run that workflow. And so here I'm able to then use my output expression here to get a list of all of those. I can then iterate through them and calculate an average. Pretty straightforward. And then I can just use a log message here to then log it out so it's easy for me to see. So this workflow I have found has been very, very useful, and there are a few ways you can modify it too. Now I created another workflow here for specifically testing scripts. So this one here has got a few differences. The first one being, now it will ask you what type of test it is. So this just creates a label that when I execute, I can then easily see, and you can see here, what I was testing in those executions. Second thing is, this is all going to run the same sort of scenario where the different programming languages are achieving the same result, but we're testing the performance of them. So to speed things up and focus on the languages themselves, I'm downloading and unzipping a CSV file that I want them to process in the main workflow and then handing that over in the subflow for them to access. This is quite useful for being able to test programming language performance because Kestra is language agnostic. So you're open to use whatever programming language you like, and some may have performance benefits over others where you might want to use one over the other. Another one that I made, which is quite useful, is this will retroactively get the execution. So this will instead look at executions that have already happened and then get you an average for those. This is less reliable because you don't necessarily know if all of those executions were successful, worked as intended. Maybe there was some errors that meant that they got ran for longer than intended. They may be running on different revisions. You don't know that. So that's why I prefer to use the one where you're running them all at the same time, but then you have to wait longer. So in this scenario, I'm able to get the executions here using the API. I am then able to process those, make sure to get all the durations, and I can calculate an average. So fairly similar, but I wouldn't say quite as reliable. So let's have a look at this example where I'm going to use these two different Python and Go workflows where they're going to download some data, they're going to add a new column, and then they're going to load that into a database. So if we have a look at the topology view here, we can see here that we're going to clone our repository. We're going to then process our code using a file that we've downloaded, and then we're going to process it and load it into a database using Postgres. So let's see what this looks like if I just execute it on its own. We should see that what it's going to do is it's going to download that file. It's going to clone the repository so that we can get the Python code we need. It's going to then transform the data we downloaded with the Python code. Once that's transformed, we're ready to load it, and we're going to load that in this scenario into a Postgres database. We can see here that once the Python code has in fact run, it loads it into a database so that we can see the result. So let's have a look at pgadmin so that we can see what it would look like inside that database. So we can see here the data has loaded and we've got our new discounted total column, which is what the Python code added. So we can see this all worked, but what if I was to now test this on a bit of a bigger scale by running this multiple times on end? Let's have a look. So I'm going to execute this workflow 10 times to see how long it takes on average, and then we can compare that to the Go version to see if Go's any quicker at doing the same thing. But the reason for running this 10 times is because we're interacting both with an external API to get the data in the first place, and we're also then interacting with a database. There may be some latency and some anomalies there, so this can help to avoid that. Now, you may be asking, why haven't I just instead looked at the Python duration rather than the whole workflow? Now, I could do that, but it would require a little bit more setup. So I could then use the API to specifically get the task run ID for that task, get the duration for it across all the executions. That's totally doable. But this is generally a bit more of a reusable scenario with a workflow for it, because here I just specify that workflow and have it go. But I guess I could have it specify a task ID too if there was a task I wanted it to look at. So here we can see it took on average 2 seconds to run the Python code. And if we wanted to be a little bit more specific, we can have a look here and see it took 2.3 there. We can see it took 2.3 in this scenario. This one took 2.4. So you get some ideas that they're all roughly similar, but this gives us a nice average without any anomalies. Now let's execute the same thing, but this time we're going to do it with Go, and we're going to see if Go's any quicker. So now I'm going to run this with Go to see if Go's any quicker over 10 runs. So let's have a look to see what it can do. And we can see here it's running pretty quickly, but we won't know necessarily till we get to the end. Now we can have a little preview at the outputs to see it took in there about 4 seconds. We can see in this one it took 3.6. So potentially this is taking a little bit longer than the Python code. Perhaps not what I would have expected, but that's the whole point of this performance testing workflow, is to help you spot those anomalies. And so we can see here at the bottom it said it took 3.44 seconds to run. Let's have a quick look to see what it took in Python. And Python reports 2.09. So here, looks like Python might be the better choice for what we're trying to do here. Probably because it wasn't hugely complicated, and so Go had to do more to get the same result. Now let's have a look at my scripting execution time. Personally, my favorite and very, very useful. So we have a bunch of different workflows here called unique ID. We've got a Golang one here that's simply going to take a file as an input, as you can see here. I'll get the topology view open. It's going to just take an input, it's going to process it, and it's just going to add a new column full of unique IDs. But it's going to calculate those using all the other columns and then generate an MD5 hash off them. So in theory, they should be the same. Now let's have a look to see how this runs compared to JavaScript as well as Python to see if there's a clear performance advantage. Now the CSV file is huge. It's got like 700,000 lines, so it will take a little bit of time. And so here is an example where, because these workflows will take a bit longer, there could be some good performance advantages to be had. So here I'm going to execute it. We're going to start with the Python one. We're going to run it for 10 runs. I've got my little type here so I can easily specify in that label what's going on. So here we're going to execute it and have a look what's going on. So it's finished. We can have a look now at the bottom to understand what our average was. It took Python 21.1 seconds. Now this is super useful because you can just let this run in the background and see how it runs. Now let's do this again, but this time we're going to do it with Go, and we're going to see if Go can do it any quicker. And we can see already that it's running pretty quickly. Each of the subflows shouldn't hopefully take much longer. So before it's taken about 20 seconds, it reckons per subflow. But here we can say it's taking about half the time. And this is all thanks to the performance workflow for helping us identify these trends. If you are interested in giving this a go, I've got a link in the description to a GitHub repository that contains these workflows. So potentially, maybe you're transforming large data and you want to understand if maybe one method or, rewriting your stuff to work in a different way is worth doing, then this could help you identify some of that. Especially where it may not be just your code that you're using. You're using a bunch of different Kestra tasks, and you want to understand if the way you've got it running is optimized for performance. It's finished running it with Go. Let's have a look. It took 8.8 seconds on average. So this is over twice as quick. So this has really helped to identify that. And the reason for doing this is sometimes when you're running things in containers, which I am here, and it's got a pollen image on that first run, it might take a bit longer than it might do on average over a longer period of time. So really good to see here. Now I want to do this one last time, but this time with JavaScript to see if JavaScript is worth using. Probably not. It's not really what JavaScript was made for, but you don't know until you test these things. So we can see here it's running. It looks like it's going a-okay. We'll have to see how it compares to Python. Looks like it's not going to be as quick as Go, but that was maybe as expected, but could give us some insights into whether we should be using JavaScript for this scenario over Python. Let's find out when we get to the conclusion. Well, this was not quite what I expected. This is taken, again, way quicker than Python. Perhaps the Python code isn't particularly well optimized, which may be true. And this is a great takeaway from this workflow, is that maybe JavaScript's better, which I find hard to believe, or the Python code is really bad at doing what it's trying to do. So here it took a little bit longer than Go. So this has given me some insight that I wouldn't have previously had. Let's probably worth having a look at that Python code, I guess. So in theory, we can now crunch the numbers on our Python script by using the retroactive flow to go look at the last 10 executions that we used in the Python workflow and see if that matches up to what we had in the other workflow that tested the performance. So it's going to get that execution data, which is going to have all the durations, and then Python's going to work out what the average is. So we can see it's successfully done it. Let's head to outputs to have a look to see what the result is. And we can see it took 23 seconds on average. And we have a look here. These are the 10 executions it fetched. So can't remember what the number was specifically for when we ran it in real time, but looking pretty similar to what we got. So pretty useful to see all of the data here. So if you want to be able to look back at executions that have run, especially if you run something on a schedule or event driven, then this is a fantastic way to do that too. Hopefully you found that useful, and maybe you're going to start performance tracking inside of Kestra. Now this is just one way of doing it that I've used, but I'd love to hear from you if you've got a different way of tracking your workflow performance too. Let us know in the comments below.